This screencast is going to be set up so that if you cannot make it to tomorrow's review session, you at least have a chance to review it on your own. This is on the 15-point practice quiz that is on the class website, and I'm just going to go over the answer key here. There's 15 points here. It should reflect what you should know and be able to do. And I'm just going to fast forward it down through the graphs and take a look at the answer keys. So check this out. The position time graph of a student who moved really fast at a constant speed or velocity away from the motion detector would have, it would both be a steep slope, it'd be a positive slope, and it would be a straight line angled upward. Away from the motion detector gave us a positive upward angled slope, so D, all the answers apply. A gently curved line that gradually gets steeper downward shows an object speeding up toward the detector. The curve implies the rate is changing, and if it's curved, it's getting steeper. It means it's speeding up. And so when we say downward with the motion detectors, we should be able to determine that it's moving towards the detector. Which of the following are vectors? Velocity, displacement, and force. Well, all of these are, all of which are indicated by a magnitude and direction. Number 4 says a student walks toward the motion detector really fast, then stops, then walks slowly away. Which of the following is false? The movement toward the detector has a steepest slope. Well, he walked fast, so it would be steepest. The stop motion would be a straight horizontal line. That's true. The movement away from the detector would have a negative slope. Not true. We just decided or defined this as a positive slope, so that's what makes C false. The velocity of each segment motion can be calculated by taking displacement divided by time, and that is also true. So letter C is the only false statement in all of that. I want to look at this graph right here. Let's see if I can get this on here. Okay, here goes. Which segment is traveling the greatest velocity? If I were to do the calculations here, this traveled from 1 meter to 2.5 meters. So that's a displacement here of 1.5 meters, and it did this in 2 seconds. So I can just extrapolate. I can put a 1 down here in my x-axis. I can put a 3 down here. It took 2 seconds. So this would be the steepest slope here. I do want you to notice that here we can calculate the negative velocity here. It traveled from 2.5 meters to 1.75 meters. And this took over 1 second. So you have to make sure you're drawing lines, you're connecting your x and y axes here. And that's very, very important that you're able to interpret the data that's inside the graph. The total displacement that the individual moved is 2.25 meters. Here's how we calculate it. So we traveled from 1 meter to 2.5 meters for a displacement of 1.5 meters, and then traveled back from 2.5 to 1.75. So that's 1.25. So excuse me, that'd be 0.75. So 0.75 plus 1.5 gives me a a distance of 2.25 meters, and displacement is from where I started to where I ended. And if I interpolate between these lines, that's 1.75 meters away. I started 1 meter away. The net displacement is 0.75 meters. So letter B is correct here. True or false? Segments A, C, and E are all constant velocity. So A, C, and E, and that is true. So which of the following is true? I'm looking at number 8. Is true about a motion graph of an object that is accelerating? Well, the graph would be a straight line. Well, that's false. It would be curved. The graph would have a curved line. It would not be straight. That is true. If it was a position time graph that was curved, that would tell me that it'd be accelerating and would not be straight. That is true. The graph would have a positive slope, negative slope. It doesn't matter the slope. You can travel you can have either one of these slopes and have it be curved. There are no true answers, and that is not a true statement because letter B is true. Moving on to number 9. I'll try to get this whole graph in here. Okay. So if I look here for the next 3 questions. So which letter represents the following motion? The student traveled from the motion detector range minimum distance to the 3 meter mark. Well, the range minimum that you found on your motion detectors was 0.5 meters, and you should know that, right? That was something that we tried to really stress. Moved away to the 3 meter mark, so that's segment E. Which letter represents the following motion? The student was stopped for 2 seconds from 1.5 meters away from the detector. So if I'm look at my 1.5 meter displacement from the motion detector for 2 seconds, letter B satisfies that requirement. And then I'm going to look here at this graph. Which letter represents the following motion? A student accelerates toward the detector from 1.5 meters to the motion detector range minimum in 1 second. Well, 1.5 meters away to the range minimum right here in 1 second. Let's see, so which letter? So you would answer this because this straight line implies it was a constant speed, not an acceleration. So answer A, B here, none. All segments are straight lines, so they are constant velocity. So be careful. I'm making sure you're paying attention to the position time. If it's accelerating, it'd be a curved line, but these are all straight lines, so there was no acceleration here. They were all constant. Lastly, 12 through 15, label segments A, B, C, and D. Which letter has a negative velocity? Notice A, B, C, and D. Segment D satisfies that. Which letter has an average velocity of 2 meters per second? And you should be able to calculate all of these. This traveled 15 meters in 10 seconds for a velocity of 1.5, positive 1.5 meters per second, 0 meters per second. This here would be a positive velocity of, let's see, 35, 20, so 20 meters in 10 seconds for, let's see, is that 2 meters per second? That's segment C, and that's the right answer. And this would be a negative velocity, so I don't even have to look at that one. What is the average velocity from A to C? So I can find from A, traveled from 0, A, B, and C, it traveled to 35 meters, so it traveled 35 meters in 30 seconds, and that is roughly 1.2 meters per second. And you should be able to calculate that. And lastly, number 15. If a net force is acting on an object, what will the graph look like? Well, it would be curved, and we've focused on this in class. Curved lines tell us that curved lines tell us that the object is accelerating, and if it's accelerating, a net force is acting. So what would the graph look like? It would be curved. And we don't have to define whether that's curved up or down, right? So that's why I curved upward. Well, that's true and that's true, but neither one of them fully satisfies the answer. It has to be curved. We don't have to define upward or downward because it can be speeding up or slowing down. So a net force just tells me that something is changing with the object's motion, and there you have it.